In this lesson, we want to learn how to find the inverse of a matrix. So in our last lesson, we talked about how to multiply two matrices together. We found that although the process is quite challenging at first because it's so foreign to us, once we kind of nail down the steps, it's not so bad overall. If you're working with kind of larger matrices, then the process is a bit tedious. But again, once you memorize the steps, it's just some simple arithmetic. It's going to be the same thing when we talk about finding the inverse of a matrix. It's going to be a tedious process when we work with these kind of larger matrices. But again, we're just doing some simple arithmetic, okay? We'll find that when we work with a 2 by 2 matrix specifically, there's a little shortcut, and I'll get to that in a little while. So the first thing we need to understand when we talk about this topic is the identity matrix, so that concept. So if I have a square matrix, an n by n matrix, that's an identity matrix, what happens is I have ones going down the main diagonal, okay? So what that means is that in my row 1, column 1, I have an entry of a 1. And then in my row 2, column 2, I have an entry of a 1. If I have a bigger matrix, let's say it was a 3 by 3, then in my row 3, column 3, I'd also have an entry of a 1. So those are your diagonal entries. Those are going to be 1s. You're going to have 0s above and below. Okay, so you'll see this and say that looks very familiar. When we did our Gauss-Jordan elimination, remember we put the left side in reduced row echelon form, which is this form here, 1s down that main diagonal, 0s above and below, and then the right side, that was what we got our answer from, okay? But here we don't have a right side. We just have this that we're working with. So this is our identity matrix, okay? Now, specifically here, when you look at this and you notate the size, because it's an n by n, same number of rows as columns, I can put one single number down here to identify the size. This is a 2 row by 2 column matrix, so I can say that this is an identity matrix, or I sub 2 to say it's a 2 by 2 identity matrix. If I had a 3 by 3 identity matrix, again, I can just say it's I sub 3. And notice how you have a 1 in row 1, column 1, a 1 in row 2, column 2, and a 1 in row 3, column 3. Again, your diagonal entries are going down that main diagonal there. 0s above and below, so that's your identity matrix. It's a similar process if you had a 4 by 4, a 5 by 5, a 6 by 6, so on and so forth. Now, why is this important? Well, this is kind of building up to something, and essentially we need to understand that when we worked with kind of real numbers, okay, outside of matrices, just real numbers, going back to kind of grammar school, we found that if we multiplied a number by 1, it was unchanged, right? 1 is the multiplicative identity in multiplication with real numbers. Well, what happens is if we take an n by n square matrix like A, okay, so that's what we say, if A is an n by n square matrix, and we multiply it by an identity matrix of the same size, right? So that's why you have I sub n there, you get A back. Now, what's interesting here, we learned in the last lesson that matrix multiplication was not commutative, right? If you change the order around, you generally speaking will not get the same product, and sometimes you could do it one way, but there's no product that's going to exist the other way. Here, you can go in two different ways. So you can say A times I sub n would give me A, and then also I sub n times A, kind of reversing that, would also give me A. Okay, so it's not a problem to kind of switch that around. So let's see a quick example of this. So what we have here is a 2 by 2 identity matrix. Again, we show this as I sub 2. The 2 tells me I have a 2 by 2. And then we have a matrix A, which is also a 2 by 2. We have -1 and 5 in the first row, 2 and 7 in the second row. So based on our rule above, we know that A multiplied by I sub 2, or again, a 2 by 2 identity matrix, should give me A back. And then additionally, I sub 2, the 2 by 2 identity matrix, times A should give me A back. So I'm just going to do this first scenario. I'll let you reverse it and do that scenario as well. Again, you get A back either way. So let's go ahead and crank this out real quick. I'm just going to erase this for right now. So first and foremost, can we do the multiplication? Of course we can, because we're multiplying two square matrices together of the same order. If we think about it, this is a 2 by 2, and this is a 2 by 2. So the columns from A, the left one, match the rows from I, okay, I sub 2, if you want to be specific, the right one. Okay, so you always circle these inside numbers and check to see if they're the same. If they are, you can proceed. Again, the size of the matrix comes from the outside numbers, so we know it's a 2 by 2. Okay, so let's go ahead and set this up. And I'll put my entries in here. And just to stay consistent with what we did in the last lesson, I'm going to put row 1 here and row 2 here. And I'm going to put column 1 here and column 2 here. Again, if you're really good at matrix multiplication, you don't need this anymore. But when you first start out, I find that it really helps students figure out what's going on. If I look at this kind of entry here, I'm thinking about, okay, this is row 1, column 1 in my answer. Okay, I always get the row from the leftmost matrix. So in this case, that's A. So I want to be in row 1 of A. So this is the first row. I get my column from the rightmost matrix, or you could say the second matrix if you want. So in this one, I have column 1. So I want to be in the first column here. Okay, so to get this entry, all I'm going to do is find the product of this row vector times this column vector. That's all it is. Okay, so we know how to do this. We go through and we say, okay, the first entry times the first entry. -1 times 1 is -1. Then we're going to add to this. We're going to have the second entry times the second entry. So 5 times 0 is 0. So we know this is -1, so this is -1. And you can see already that your first entry in this matrix matches what it is in A. Okay, so as we continue, now if I move into this position here, I'm still in row 1. Okay, so for A, I'm still going to be in row 1. But now I'm shifting to column 2. So for this guy, I'm going to be in column 2. Okay, so that's all it is. Same process. I'm going to do this one times this one. So -1 times 0 is 0. Then plus, I'm going to do this one times this one. 5 times 1 is 5. We know 0 plus 5 is 5. And again, we can see this matches exactly. So now, what I'm going to do is shift. Because I'm going to be in row 2 down here now, so I'm going to start in row 2 here, and I'll have column 1 here. Okay, so row 2, column 1, this guy right here. So 2 times 1 is 2, plus 7 times 0 is 0. This equals 2, so I get a 2 there. And again, this matches perfectly with A. So let me erase this now. We're going to move on to kind of this one. So for the last entry down here, you're in row 2, column 2. So you've got the row from A and the column from I. Okay, so you've got 2 times 0, which is 0, plus you've got 7 times 1, which is 7, which gives me 7. So I put a 7 there. So you can see that we multiplied our matrix A by our matrix I sub 2, or the 2 by 2 identity matrix, and we got A back. Again, if you want to pause the video and reverse this, if you wanted to do I sub 2 times A, you would get A back as well. Okay, so now let's move into talking about how to find the inverse of a kind of square matrix. So first we're going to define a word here. So we have this non-singular word, okay? And that just means that the matrix is going to have an inverse. So when a matrix has an inverse, we say it's non-singular. You might also see the term invertible, okay? So those two words kind of mean the same thing. You might see non-singular in one textbook, you might see invertible in another, just depending on where you're kind of getting your information from. If you have a matrix that doesn't have an inverse, and we'll see an example of this in a little while, it's known as a singular matrix, okay? So if A is a non-singular, meaning it has an inverse, n by n square matrix, then this property is going to be true. If I take A and I multiply it by the inverse of A, okay, then I'm going to get an identity matrix of the same order. Again, I just put that in there to say it's in n by n. So if A was a 2 by 2, the inverse of A would be a 2 by 2, and then this identity matrix would be a 2 by 2. So let's show an example of this real quick. I'm giving you A, and I'm giving you A inverse, okay? And what we're saying is that if you multiply A by its inverse, you're going to get the identity matrix. In this case, you would get an I sub 2 because it would be a 2 by 2, okay? So let's crank out A times A inverse, and you could reverse this. You would still get the identity matrix, okay? It wouldn't matter. So what this is going to give me is what? Let me kind of write this out. I know that it's a 2 by 2 times a 2 by 2, so the answer will be a 2 by 2, okay? So this is row 1, this is row 2, column 1, and column 2. So I know for this guy right here, row 1, column 1, I want this row here from the first one times this column here from the second one. So this row vector times this column vector, what is that? So we have 3 times 1, which is 3, plus we have 1 times -2, which is -2. And we know this is going to give me 1. So I've got a 1 there already. Okay. Now let's move on. So now I'm going to erase this, and I'm going to move to this column here. So this guy, 3 times -1 is -3. Then plus 1 times 3 is 3. And this is going to be equal to 0. So that's going to be this entry here. Okay. So now we're moving into this row down here. So let me kind of switch up my highlighting. I know I'm going to be in this row here and this column here to start. So 2 times 1 is 2, and then plus 1 times -2 is -2. This equals 0. So let me write that in here. And then let me erase this. One more to do. And let's just highlight this now. So we'd have 2 times -1, which is -2, plus 1 times 3, which is 3. And obviously this is 1. So we have our identity matrix. We have our I sub 2, which is exactly what we were told from this rule here. Okay? So now that we've proven that this is true with a simple little example, let's talk about how we could find A inverse if we didn't know it, okay? So I'm going to give you the shortcut first, okay? And then I'm going to show you kind of the long way. This shortcut that I'm going to give you is only going to work for a 2x2 matrix, unfortunately. When you get something larger, you have a few different techniques that you can choose from. The one I'm going to show you today is the one you're going to see in your textbook. There's other methods that you can use. They're not a big difference in time. It just kind of depends on which kind of method you find less tedious. I can tell you that this is not a process that is very enjoyable, okay? So for the 2x2, the shortcut goes as follows. So I'm going to define A, just generically, to have these kind of entries of lowercase a, lowercase b, lowercase c, and lowercase d, okay? Now, we haven't yet talked about the determinant of a matrix yet. We'll get to that in 2 lessons from now. But for now, it's very easy for a 2x2 matrix. It's just this guy times this guy. So it is A times D, then minus, you're going to go this times this, so minus B times C. Okay, so that's the determinant of A. A lot of times you'll see DET of A like this. There's a lot of different notation for this, and I'll talk about that when we get to that video. For now, you just need to know this is the determinant of A. Okay, so let me erase this real quick, and let me erase this. I'm just going to drag this up here a little bit so that we know what this is. Okay, so the way we find A inverse is that we're going to go 1 over the determinant of A, and we're going to multiply this by, we're going to do a little kind of swap-a-roo here. So I'm going to take A and D and I'm going to swap them. So I'm going to put D here and A here. And then I'm going to make C and B into their opposite. So I'm going to have the negative of B and the negative of C. Now, the first time you kind of see this, you're like, what in the world is going on? But after you do this a few times, it's something you just memorize. And I can tell you this comes up very often. It's a very good shortcut. It's going to save you a lot of time. Okay, so let's say that I replace this with these numbers here. And I know they're already copied, but let's just say we have 3, 1, 2, and 1. And so I know that my A, my lowercase a is 3, my lowercase b is 1, my lowercase c is 2, and my lowercase d is 1. Okay, so let me start out by going 1 over the determinant. Again, the determinant is 3 times 1, which is 3, minus 1 times 2, which is 2. So that's going to be 1. Okay, so 1 over 1 is 1. Okay, so that's pretty simple. Then times, I'm going to do this stuff here. So these guys switch positions. So the 3 and the 1 switch. So 1 goes here and 3 goes here. And then what's going to happen is this guy right here and this guy right here, I change them into their opposite. So this is -1 and this is -2. We already know that 1 times this in scalar multiplication just is itself. So I know that A inverse is this. And again, we already know that that's the inverse, right? I have a 1 and a 1, a -1 and a -1, a -2 and a -2, and a 3 and a 3. So not too bad overall compared to what I'm about to show you. So let's talk about the long way now. And this is something you'll see in your textbook. I'm going to show you later on at the very end of the video, for those of you who want to see it, where this kind of thought process comes from. I'll start out with a 2x2 matrix and I'll go through the whole thing and I'll show you why this makes sense. But for now, if you don't want to look at that, you can just take it as a given, okay? So if you want to find the inverse of an n by n non-singular matrix A, so this works for a 2x2, a 3x3, 4x4, whatever you want to use it on, okay? You start out by basically setting up this in step 1. So you're going to put your augmented matrix where matrix A goes on the left and the identity matrix of the same size, okay, goes on the right, okay? Then what you want to do is you want to use row operations to get this guy into the format of being the identity matrix, and then this guy on the right, which we'll call matrix B, okay, the result of doing the row operations to getting this guy into that format, B is now going to be the inverse of A. Okay, and again, I'll show you exactly where this comes from at the end of the lesson. The process takes a little while, so I know some of you don't want to watch that. All right, so let's go back, and I want to grab A real quick, and I'll show you that you end up with the same thing. So let's just take this real fast. I'm going to copy it, and I'm just going to paste this in here real quick, and I'll show you that you get the same result either way. So what I want to do is I want to take this matrix here, this 3, 1, 2, and 1. And then I want to put a vertical bar, and I want to write my identity matrix of the same size. So 1's going down the main diagonal, a 0 above and below, okay? So what I'm going to do is I'm going to use row operations to get this side over here to look like this over here. I want this side to be an identity matrix, and then this side would give me the inverse, okay? So what we're going to find is that we're going to end up with a right side that matches this, okay? So let's go ahead and do our kind of row operations. We already know that this process kind of, for lack of a better word, is very tedious, okay? So the book usually tells you to get a 1 here first and then use that to get your zeros. There's other methods you can use. I'm going to stick with that method. I know there's kind of quicker ways, but I'm going to stick with that because I don't want to confuse you, okay? So the first thing I'm going to do is I'm going to multiply row 1 by a third so that that entry becomes a 1. So I'm going to do 1/3 times row 1. That's what I'm going to replace row 1 with, okay? So this 3 would become a 1. This guy would become a 1/3. This would be a 1/3, and this would stay 0. So let me erase all of these entries, and let me put these in. This is 1, 1/3. This is 1/3 again, and this is 0. Okay, so that's the first step. Now the second step is to get a 0 here, and to do that I'm going to use my 1 that's above that, okay? So I think about the opposite of 2, which is -2, and I would say 1 times -2 would give me -2. If I added -2 to 2, that would be 0. Okay, so what I want to do is I want to take -2 and multiply it by row 1, add the result to row 2. That's what I'm going to replace row 2 with. Okay, so let's go ahead and do that real quick. So if I did -2 times 1, that would give me -2. And then if I added that to 2, I would get 0. Okay. Then if I did 1/3 times -2, that would give me -2/3. So -2/3. And then I'm going to add that to +1 or 3/3. And if I add those two amounts together, -2 plus 3 is 1. So I'd have 1/3. Okay. And my screen's going to get too busy, so let me kind of fill these in as I go. So this is a 0, and this is also a 1/3. So let me erase this. We don't need this anymore. And then for this one right here, I'd multiply -2 times a third. Okay, so that would give me -2/3. And then I'm going to add the result to row 2. So I'm going to add 0. We know that would still be -2/3. So this is -2/3. And this one's not going to move at all because -2 times 0 is 0. 0 plus 1 is 1. Okay, so that part is done. And just a little bit more to go. So now I want to make this a 1. Okay, so I would just multiply that whole row by 3, right? The reciprocal of 1/3. So 3 times row 2 would give me my new row 2. Okay, so 0 times 3 is 0. 1/3 times 3 is 1. If I did -2/3 times 3, I know that the 3's would cancel. I'd have a 1. -2 times 1 is -2. So this is -2. And then I know that 1 times 3 is 3. Okay, so I can just put a 3 in there. And you can already see that the kind of bottom row here works out to be this. Okay, but we got to make this a 0 now. Okay, so what I'm going to do is I'm going to multiply row 2. I'm going to multiply row 2 by the opposite of 1/3, which is -1/3. I'm going to add the result to row 1. Okay, that's what I'm going to replace row 1 with. So I'm going to do 0 times -1/3, that's 0. 0 plus 1 is still 1. 1 times negative 1/3 is negative 1/3. Negative 1/3 plus 1/3 is 0. So that's going to be 0. And then negative 1/3 times negative 2 would be positive 2/3. And I can erase that sign, I don't need it. Then plus 1/3. Well, this would be 1, right? 2 plus 1 is 3. 3 over 3 is 1. So this becomes a 1 here. And then lastly, okay, I would do a negative 1/3. A negative 1/3 times 3. And we know this cancels with this and gives me a 1. Negative 1 times 1 is negative 1. Okay. And I would add that result to 0. So that would be negative 1. Now, you can see here, once the process is done, this here matches this here. So that's exactly what we said in our instructions, right? Once you kind of start this way, you use your row operations, you get in the format of the identity matrix is on the left, and on the right, you're going to have the inverse of your matrix. And we know that that's true already because we know that A inverse is the inverse of A because we already showed that, okay? So that's another way to go about doing it. If you have a 2x2, it's not something you really want to do because it just takes too long. You want to go ahead and use the shortcut. So that's the only time I'm going to use that there. I want to show you an example of a singular matrix, okay? So I'm just going to do one with a 2x2. And what you're going to find is that it's singular, or meaning it doesn't have an inverse because the determinant is going to be 0, okay? The determinant is going to be 0. So if you use row operations here, you're not going to be able to get it into the format that you want. But again, we're going to use our shortcuts. So I'm going to say that A inverse is equal to 1 over the determinant of A. So 3 times 4, which is 12, minus 6 times 2, which is 12. So once you see that this is a 0 down here, the determinant, you can stop and say this is a singular matrix, okay? It's not going to have an inverse. So you don't need to go any further. I know the rest of it was to kind of multiply it by this. These two guys would switch, so you have 4 here and 3 here, and these guys become their opposite, so negative 6 here and negative 2 here. But the whole thing is blown, okay, because you have a 0 in the denominator, and we know we can't divide by 0. So this isn't going to work. There's no inverse. All right, so let's take a look at an example with finding the inverse of a 3x3 matrix. Again, as I said earlier, when you get a 3x3 or a 4x4, there are some tricks out there, there's some different techniques, but none of them are pleasant, okay? And you basically have to pick one of them and then grind through the work. So we're going to look at the method that we learned today. So basically, I'm just going to copy this guy right here. And I'm going to say I have a 1, a negative 1, and a 1. A 0, a 4, a negative 2, and then I have a 2, a 3, and a negative 1. Okay, so that's the first part. Remember, you copy your matrix you're trying to find the inverse of on the left. You're going to put your kind of vertical bar in here, and then I'm going to write the identity matrix on the right. So I'm going to put a 1 here, a 0 here, and a 0 here, then a 0, a 1, and a 0, and then a 0, and a 1. Okay, so again, 1's going down that main diagonal, 0's everywhere else. So you could say 0's above and below. So let me go ahead and copy this because we won't be able to fit this on this page. And let's go ahead and paste this in here, and we'll just go through the work. All right, so we want to take the left side here and transform it into the identity matrix, or you could say you're putting it in reduced row echelon form. And again, through that process, the right side here is going to give us our inverse matrix of A, okay? So the first entry here, we always want to get a 1 here if you go by what your book tells you, right? You get your 1 first in the column, and then you use the 1 to get your zeros. Okay, so that's already done for us. So what I want to do is concentrate on getting a 0 here and then getting a 0 here. Okay, so let's do those one at a time. So I know that I can multiply row 1 by 1, which is just the same thing as having the row itself, and then add the result to row 2, because 1 and negative 1 are opposites. That's going to give me a 0 for that entry there. So the way I'm going to write this is I'm going to say 1 times row 1 plus row 2 is going to give me my new row 2. You can get rid of the 1 if you want. I'm just going to put it there for kind of emphasis. Okay, so let's go through and basically just say that we're adding row 1 to row 2, and that's what we're replacing row 2 with. So 1 plus negative 1 is 0. Let me make that a little better. And then 0 plus 4 is just 4, so that's going to stay unchanged. 2 plus 3 is going to be 5. 1 plus 0 would be 1. 0 plus 1 would be 1, so that stays 1. 0 plus 0 is obviously 0, so that stays as a 0. All right, so that's the first step. Then the second step here, again, we want to get a 0 here. So to do that, I want the opposite of 1, which is negative 1. So I'm going to multiply row 1 by that. So negative 1 times row 1. Then I'm going to add the result to row 3 down here. That's what I'm going to replace row 3 with. Okay? So let me just go through and multiply everything by negative 1. So 1 times negative 1 is negative 1. 0 times negative 1 is 0. 2 times negative 1 is negative 2. 1 times negative 1 is negative 1. 0 and 0, if I multiply either of those by negative 1, I get 0. Okay, so those are going to be your entries that you add to this row. So negative 1 plus 1 is 0. 0 plus negative 2 is negative 2. Negative 2 plus negative 1 is negative 3. And let me just erase these because we're done with them. Okay, and then negative 1 plus 0 is negative 1. And then obviously if I add 0 to something, it's unchanged, so I don't need to worry about the rest of those. Okay, so now let's move into the next column. Again, if you follow what your book tells you, and you don't have to, you can do it different ways, you want to get a 1 first. Okay, so I'm going to put a 1 right there in row 2, column 2, okay, considering the left part of the matrix. And to do that, I'm just going to multiply row 2 by 1/4, right, the reciprocal of 4. So 1/4 times row 2 is what I'm going to replace row 2 with. So we know that 0 times a fourth would just be 0, so that's not changed. 4 times a fourth is 1. And then we know this would be what? It would be 5/4. So 5/4. This would be 1/4, and this would be 1/4. So let me just change that in each case. And then lastly, we know 0 times 1/4 is 0. So that's done. So now, conveniently, I already have a 0 above. I just need a 0 below. Okay, so to do that, I'm going to use my 1, and I'm going to multiply row 2 by the opposite of this negative 2, which is 2. So 2 times row 2, and then plus my row 3, that guy right there, is going to give me my new row 3. Okay, so let me just multiply everything by 2. So 2 times 0 is 0. Then we have 2 times 1, that's going to be 2. Then we have 2 times 5/4. So 2 times 5/4. So this would cancel with this and give me a 2 down here. So that's going to be 5/2. So 5/2. And then 2 times 1/4, we're doing that twice. So we know that this cancels with this and gives me a 2 down there. So in each case, I'm going to have a half. So I'm going to have a half here, and I'm going to have a half here. Okay? And then lastly, 0 times 2 would be 0. So that's the result in each case of doing 2 by each one of these guys, okay? So now we want to take these results and add them to the entries in row 3. 0 plus 0, obviously that's not going to change. 2 plus negative 2 is going to give me 0. This one, and this one is going to be a little bit of work. So let's do those off to the side. So we have 5/2 plus a negative 3. So negative 3. So I need a common denominator. I'm going to multiply this by 2 over 2. So I could say this is negative 6 over 2. So negative 6 over 2. 5 plus negative 6 is going to be negative 1. So this is negative 1/2. Okay, so this is negative 1/2. So that's what I'm going to replace this guy with. Negative 1/2. Okay, so let's move on now to this one. So what we have is 1/2 plus negative 1. So 1/2 plus, for negative 1, I'm just going to write it as negative 2 over 2, okay? And so negative 2 plus 1 would be negative 1, so this is negative 1/2. So this is negative 1/2. And obviously, 1/2 plus 0 is 1/2, so that one's easy. And then 0 plus 1 is 1, so we don't have to do anything there. Okay, so now we are getting close to the end, okay? So we want to get a 1 here as our first thing to do in this kind of column here. So to do that, I'm just going to multiply row 3 by the reciprocal of negative 1/2, which is going to be negative 2. So negative 2 times row 3, that's going to give me my new row 3. And so let's go ahead and do that. We know that this and this would be unchanged because they're zeros. 0 times anything is 0. This guy would obviously be a 1. So I really only need to work on these. And I know that this one right here, this 1 would just be negative 2. So let's work on this one and this one. Okay, so negative 2 times negative 1/2. We know that this would cancel with this and be 1. So you basically have what? You have negative 1 times negative 1, which is positive 1. So this is going to be positive 1. And then in the last case, you have it negative 2 times 1/2. And so this cancels with this and gives me a 1. Negative 1 times 1 is negative 1. So this would be negative 1. Okay, so we have the bottom row here complete. And now what we want to do is get a 0 here, and we'll be done. Okay, so I'm going to multiply row 3 by the opposite of 5/4, which is negative 5/4. Add the result to row 2. Okay, you already know what's going on. So for these first two, it doesn't matter because I'm multiplying by 0. So anything by 0 is going to be 0. And then if I add 0 to something, it's not going to change. So I don't need to worry about those entries. I know that if I multiply negative 5/4 by 1, I get negative 5/4. If I add it to 5/4, I get 0. So I really don't need to worry about that either. Okay, I only have to work on these over here. So let's kind of do these entries real quick. So negative 5/4 times 1 is negative 5/4. Then we have negative 5/4 times negative 1, which would be positive 5/4. And then negative 5/4 times negative 2, what would that give me? Well, I know it's going to be positive, so I can just erase these signs. And I can cancel this with this and put a 2 down here, so that's going to be 5/2. Okay? And let me get rid of this sign here. We really don't need it. It's just for emphasis. Let me kind of drag these up a little bit more. All right, so let me just kind of put commas between them so we know what's going on. All right, so let's start with this guy right here. We would have 1/4 plus this negative 5/4. We have a common denominator already, so we have negative 5 plus 1, which is negative 4. So this gives me negative 4 over 4, which is negative 1. Okay, so this is negative 1. So I can erase this, don't need that anymore, and erase this. And then now I'd have 5/4 plus 1/4. Okay, so 5 plus 1 is 6. So you'd have 6 over 4, which reduces to 3/2, right? Each is divisible by 2. So this is going to be 3/2, okay? And then obviously 5/2 plus 0 is just 5/2. All right, let me make this better because that doesn't look so good. Okay, so we have that completed now. And we just need to get a 0 in this entry here, and we will finally be done. All right, so how can we do that? We multiply row 3 by negative 2, the opposite of 2. So row 3 gets multiplied by negative 2, add the result to row 1. Okay, so we don't have to worry about, again, these entries to the left of this because you have negative 2 times 0, negative 2 times 0, it's going to be 0. Add 0 to something, it's not going to change. I know this is going to be 0 because negative 2 times 1 is negative 2, negative 2 plus 2 is 0, so that's taken care of. So I really don't have to worry about these entries over here. Okay, so what is negative 2 times 1? It's negative 2. What is negative 2 times negative 1? It's positive 2. What is negative 2 times negative 2? It's going to be 4. Okay, so let's add these. Negative 2 plus 1 is going to give me negative 1. Then next, you're going to have 2 plus 0, which is going to give me 2. And then lastly, you're going to have 4 plus 0, which is going to give me 4. Okay, so we've completed our process. All right, so just to recap what we did, we started out with A on the left and the identity matrix and I sub 3, because it was a 3 by 3, on the right. We used row operations to basically transform the left side into an identity matrix. We'll say I sub 3 because it's a 3 by 3. And then the right now, let's just call this B, or you could just say it's A inverse, right? Because it's the inverse of A at this point, okay? So that's the process. That's how you do it. If you wanted to say, we can just copy this real quick, go back up, and let's just paste this in. We can say that A inverse, okay, is going to be this part right here, okay, on the right. So let me just kind of set this up. We'd say negative 1, and 1. You would have 2. You would have 3/2 and negative 1. You would have 4. You would have 5/2 and negative 2. And so that would be the inverse of this matrix here. And again, this process is going to work if you have a 4 by 4 or a 5 by 5 or something like that. Obviously, those problems get very, very tedious, and there's some tricks out there. But usually in your course, you're only going to be given a 3 by 3, and occasionally, maybe for like a bonus question, they'll give you a 4 by 4. These guys who are teaching these classes, they understand how tedious this process is. All right, so let's wrap up the lesson by kind of returning to this generic formula. I want to show you where this comes from. Some textbooks show you where it comes from, and you might get lost if you're trying to read it. Other textbooks just skip it, okay? So if we find the inverse, again, of an n by n non-singular matrix A, again, the first step is to put this kind of augmented matrix there where A, what you're trying to find the inverse of, is on the left, and your identity matrix is on the right. Then through your row operations, the left side, you change that into the identity matrix. One's going down the diagonal, zero's above and below. And this matrix that's formed on the right, let's just call it B, is the inverse of A. So where does this come from? Let's go ahead and start with a fresh example, okay? So we have A, and it's equal to this. We have 5 and -1, and we have 3 and 6. So let's start out by using the little shortcut to figure out what we should get. So again, A inverse, if we use our shortcut, is equal to 1 over the determinant of A, which is 5 times 6, which is 30, okay, minus -1 times 3, which is -3, minus the negative is plus a positive, so this should be plus 3. So this would be plus 3 here, so this would be 1 over 33. So it would be 1 over 33 times, okay, remember the little trick you have to do over here. You switch these two, so this becomes a 6 and this becomes a 5. These two become their negatives, or you could say their opposites. So this would be -3 and this would be +1, okay? So if I did, let me kind of do this down here, I'll continue. And I need a bigger bracket. So 1 over 33 times 6 would be 6 over 33. Of course, each is going to be divisible by 3 there. 6 divided by 3 is going to give me 2. And 33 divided by 3 is going to give me 11. So that's my first entry. Then over here, if I did -3 over 33, each is divisible by 3. This would be a 1, and this would be an 11, okay? And then for this entry here, 1 over 33 times 1 would just be 1 over 33. And then for this last entry, I would have 1 over 33 times 5, which is 5 over 33, okay? So that would be A inverse. And let me just kind of write this over here. Let's kind of scooch this up. Now, let's say that you didn't know that shortcut, and you didn't know the rule that I just gave you, okay? So you didn't know about kind of going through the process. How could you figure this out? How could you derive the formula? Well, if I just started out with the notion that A times A inverse gives me an identity matrix, in this case it's going to be a 2 by 2, well, I can come up with a little formula. So let's kind of go down a little bit. Let me just copy A real fast. So it's 5, 3, -1, and 6. Let me copy this real fast, and I'm going to go to a fresh sheet. We'll come back there and we'll check our answer eventually. So we have this guy here, and I know that if I multiply it by its inverse, let's just say I don't know what that is. We'll say it's X, Y, W, and Z. These are just kind of stand-ins for those entries, okay? We know that if we multiply these two together, if they're inverses, I get an identity matrix that's a 2 by 2. So 1's down the diagonal, and I've got 0's above and below. So we know this. So what I would do is I would say, okay, I can multiply these two together. So the way I would do that, I know I would get a 2 by 2 matrix. And I need a lot of room here, so let me just not put my brackets in yet. I know for this entry here, I would do this row times this column. So 5 times X is 5X. And then I would have plus -1 times W, so minus W. Then for this entry, I would do this row times this column. So 5 times Y is 5Y. And then -1 times Z, we'd have minus Z. Okay, then for this entry, I would do this row times this column. So I would have 3X plus, you'd have 6W, okay? And then lastly, I would do this row times this column, 3Y, okay, plus 6Z. All right, so far, so good. Now I know that this guy, if I set it equal to this, what has to be true? Let's think about what we know so far, or what we've learned in kind of previous lessons. We know that two matrices can only be equal if and only if their size is the same. In each case here we have a 2 by 2, and their corresponding entries are exactly the same. So what that means is that this guy right here, this 5x minus w, must be equal to 1 if this is true. Okay. We also know that 5y minus z must be equal to 0. Again, corresponding entries. So this guy right here, this 3x plus 6w must be equal to 0. And this guy right here, this 3y plus 6z is equal to this one here. Okay. So far, so good. Now, let's go down a little bit and let's continue to think about what's going on. I have 4 variables that are unknown, and I can solve it here because I can split it into kind of 2 different systems with the same 2 variables each. So on the left, I'd have a system with x and w. On the right, I'd have a system with y and z, okay? Now you can go through and solve this pretty quickly, but what I'm gonna do is solve it. It's gonna take me a little bit longer, but I wanna show you what your book's gonna do. So I would solve this using a kind of augmented matrix. So in the first one, I would have kind of the way this is lined up. I have my x on the left and my w on the right, okay, of this left side of the equation. So 5 and -1 and 3 and 6. And notice the order is important. I've got to have the x lined up and the w lined up so that this column is the x's, this column is the w's. So this is for the x's, this is for the w's, right? Then this guy is going to give me my constants, my 1 and my 0. Let's stop and think about this for a second. I know that if I put this in reduced row echelon form, this guy would be a 1, this would be a 1, this would be a 0, and this would be a 0. So x, 1x plus 0w would be this. So this guy is going to give me what x is, okay? And similarly, this guy is going to give me what w is, okay? So let's erase this and let's just keep that information so we keep track of what's going on. Now, similarly, I can set up this system over here, 5, -1, 3, and 6. And through a similar thought process, I can say that this guy right here is going to be my answer for y when it's done, and this guy right here is going to be my answer for z, okay? And I'm going to erase this kind of circling. We don't need that, and it would just get in our way. Okay, now what do you notice here? This is where people get lost in this process. The left side here matches the left side here, right? 5, -1, 3, 6, 5, -1, 3, 6. Okay. So what happens is if I'm going to solve this using row operations, what I do on this would match what I do on this. They're the same numbers, right? So what your book's going to do, they're just going to erase this, and they're going to squeeze this down and say, hey, I'm going to combine these 2 operations because I can. And what's going to happen is I already know, I've already kept track of what's going on. So when I put this guy into reduced row echelon form, or I make it into its identity matrix, okay, then I can get my answer by saying this is what x is, this is what w is, this is what y is, and this is what z is, okay? So let's copy this and go to a fresh sheet. And we'll paste this in, and we'll finally crank this out. And I know this takes a while, but nothing kind of worth seeing is quick, okay? So let's go through and use our kind of row operations. We're trying to get this left side here into reduced row echelon form, or again, you could say the identity matrix. So the first thing I would want to do is get a 1 here. So how would I do that? I would multiply row 1 by 1/5. That's what I'm going to replace row 1 with, okay? So I know that this would be a 1. I know that this would be a -1/5. I know this would be a 1/5, and this would stay a 0. So that's pretty easy. Then the second thing I would do is I would make this into a 0. So I would multiply row 1 by -3. I would add the result to row 2. That's what I'm going to replace row 2 with. So -3 times 1 is -3. -3 plus 3 is 0. Then -3 times -1/5 gives me what? -3 times -1 is 3, and then over 5. So this is 3/5. And then I'm going to add to this 6. So I'm going to have 3/5 plus, might as well say 6 is 30 over 5. Okay, so this would be 33/5. This is 33/5. All right. And then we have -3 times 1/5. That's -3/5. If I add that to 0, it's just -3/5. So that's pretty easy. And then lastly, we have -3 times 0. That's 0, so we don't have to worry about that. So that part is done. Now, let me get this to be a 1. So I'm going to multiply row 2 by 5 over 33. That's what I'm going to replace row 2 with. And so we know this is a 1. We don't even have to worry about this. This right here, if I did 5 over 33 times -3/5, the 5s are going to cancel. The 3 over the 33, we know they're each divisible by 3, right? So we say this is a 1 and this is 11. So this right here is going to be -1 over 11. And we know that, lastly, I'm going to have 5 over 33 here, right? Because 1 times anything is itself. All right, so one more thing to do here. I just have to make this into a 0. And to do that, I'm going to multiply row 2 by 1/5. And I'm going to add that result to row 1. That's what I'm going to replace row 1 with. Let me kind of slide that down because it took a little bit too much room. Slide that over here. All right, so 1/5 times 0 is 0. Don't have to do anything with that. 1/5 times 1 is 1/5. 1/5 plus negative 1/5 is 0. All right, so now I'm going to do 1/5 times this negative 1 over 11. Okay, so that's going to give me negative 1 over 55. Okay, so negative 1 over 55. And I'm going to add to this 1 over 5. So to get a common denominator going, I'm going to multiply this by 11 over 11. Okay, so that would give me 11 over 55. And if I add these two amounts together, I'm going to get 10 over 55. Now I can simplify this because each one of these guys is going to be divisible by 5. If I go ahead and cancel a 10 with a 5, 10 divided by 5 is 2. And 55 divided by 5 is 11. Okay, so that's what I'm going to replace this with. This is going to be 2/11. And then lastly, I'm going to have 1/5 times 5 over 33. And so this cancels with this and gives me a 1. I'm going to have 1 over 33. So 1 over 33 plus 0 is just 1 over 33. Okay. So let's erase all of this. Didn't mean to erase that bracket. And let's kind of copy this real fast. So let me paste this in here real quick. And I'm saying that this guy right here should be 2 over 11. So this is my x. It should be 2 over 11. This guy right here should be 1 over 33. And this guy right here should be negative 1 over 11. And this guy right here should be 5 over 33. Okay, so we already know that this is the case because we found it using the shortcut. So let me copy this real quick. So let me just paste this in here real quick. And let me erase this. So what you see is that you have A inverse, right? This is exactly what we found from the shortcut. You have 2/11 and 2/11, 1 over 33 and 1 over 33, negative 1 over 11 and negative 1 over 11, 5 over 33 and 5 over 33. Okay, so it's the same. And what's cool about this is that we ended up deriving kind of this formula that we see in our textbook, right? So we ended up saying that A times A inverse gives me the identity matrix. We had to set up some kind of variables to represent our unknowns for the A inverse. But what we ended up with was solving kind of a system that's set up this way. We had A on the left, and we had the identity matrix on the right. We tried to solve this system, so we try to put this guy in reduced row echelon form, where we have 1s down the diagonal, 0s above and below. So that's the identity matrix, right? And then once we got in this format, we found that this guy right here ends up being the inverse, okay, of what we started with, which was A. So really cool to know where that comes from. If you were reading that in your textbook and you got lost, now you know the steps, now you know how it works. And you could really do this with a 3x3, a 4x4, whatever you want. You could extend what we just did out to as large of a system as you wanted to work with. Again, as long as you're working with a matrix that's invertible or, again, non-singular.